Hi, my name is Shengmei. I'm a PhD student in computer science at Worcester Polytechnic Institute, an engineering school near Boston, Massachusetts. My research area is latency and gaming. Today, I will present our work, Effects of Variation in Frame Rate on Game Player Quality of Experience. Frame rate is a well-known term, which means how many times the pictures are displayed to the screen in a second. For example, 30 FPS means 30 pictures displayed per second. Frame time means how long it takes for a frame of picture to be displayed on the screen. It's the delta between the display time of the current frame and the last frame. Higher frame rate, shorter frame time. And on the top, we have consistent frame rate where the pictures come out regularly and smoothly. The frame time of the frames are the same. But instead of the consistent frame time, we are studying the frame time with variation. Now we have the inconsistent frame rate with variation. Here, some frames are rendered faster and some are slower. The frame time here is inconsistent. The slower frames will have longer frame time and the faster frames will have shorter frame time. And there is a variation across the frame time. There could be many possible sources of variation. The variation may come from both the hardware and software, also the game itself and the graphic settings. Variation in frame time is known to degrade player experience in games. However, it is not clear how much does the lower frame time variation help players' quality of experience. We aim to quantify the effects of frame time variation on players and provide a model where QE is a function of variation. We want to collect data on QE and frame time variation and find the right metrics which represents variation. Then we will do mathematical modelings and provide a model which can precisely predict players' quality of experience given frame rate variation. The model can benefit many groups of people. For example, gamers would know how do they change in-game settings for better experience. The game developers would learn how should they optimize their game code for better variation. And hardware companies can leverage the results and decide how can they integrate technologies for more stable frame rate. Our methodology is to run a user study. For each of the game, there are two base frame rate, 60 and 120. The frame rate is kept by a tool called RTSS. The variation is controlled by task loaders, and there are 7 conditions for each frame rate. Perfect condition without any loaders. 2 noticeable conditions where the frame rate variation are noticeable to players. Playable, where the game is barely playable. For the 4 conditions, you can find games and the corresponding number of loaders in the table. For the 3 games we selected, the number of loaders are the same for game Valorant and Strange Brigade. They are higher for game Rocket League because Rocket League is more tolerant to frame rate variation. Other than the 4 consistent loaders condition, there are 3 chaos rounds with a combination of all the 4 conditions. The order of all the game conditions are randomly shuffled, but the players will finish all the game rounds of one game before proceed to the next game. For each of the game, players will finish all the rounds for 1 FPS before proceed to another FPS. There is 1 extra practice round without any loaders for each of the game. Each of the game round lasts for 1 minute, and players usually spend about 20 minutes for a game and about 1 hour for the user study. We have an in-game survey after each round asking about their experience. There are 2 questions in the survey. The first question is a widely used mean opinion score question. Rate the quality of the previous game round. The second question asks if the experience is acceptable. And there is error control for both of the questions. We have a script that controls launching of games and QE surveys automatically. We propose many different metrics for frame rate variation and see how well they fit our data. We will first introduce frame rate average. The frame rate of every frame is recorded, and this metric is the average across a game round. In this graph, the x-axis is frame rate average, and the y-axis is the QE. We divide the data from the 120 Hz rounds by 2 and combine the data of 120 Hz and 60 Hz. The blue circles are the mean values across the 6 consistent loaders conditions, and the bars are the 95% confidence intervals across the mean values. From this graph, the blue points are way off the line, showing that frame rate average is a bad predictor for QE. The next metric is time between display change standard deviation. We fit the models with data from games with consistent loaders conditions, and then validate the model with data from the chaos rounds. This graph is as last graph, but the x-axis is time between display change standard deviation. We can see that the time between display change standard deviation fits our data well with R-square at 0.99. We can learn that this metric fits our data well. We then validate the model using the chaos rounds data. The axes are as graph on the left. 3 colors of points represent data from the 3 different games. We can see that time between display change standard deviation did not fit the individual games well, and that this metric might not be accurate for specific games. The next metric is frame rate 95% floor, which means 95% of frame rates are greater than this number. This graph is frame rate 95% floor versus QE. The x-axis is frame rate 95% floor, and the y-axis is player QE. From the R-square value at 0.97, we can see that the frame rate 95% floor fits our data well. The graph on the right shows validation using the chaos rounds data. We can see that the frame rate 95% floor also fits the individual games well. As a conclusion, frame rate 95% floor is an effective predictor for QE. For the future work, we will investigate other sources of variation like Zoom, like VR, and we will study more games and game genres. We want to examine the difference based on player expertise and see how frame rate variation affects players from different skill groups differently. And finally, we want to apply results to different areas, probably beyond games. Thanks for your attention on our work.